In this video, we will discuss the problem pairs of non-coinciding points. The problem says that you will be given a Cartesian plane and there are n points in it. You need to find the number of pairs of points a comma b such that these two conditions hold. The point A and point B should not coincide, so they should not be the same point, and the Manhattan distance and the Euclidean distance between the two should be the same, right? So it is saying that suppose you have been given 2 points. Let's say the 2 points are x1 and y1, right? And suppose the other point that is there, that is the first point, let's say is A, the second point let's say is B, that is nothing but x2 y2. So it is saying that you have to check that x1 is not equal, like this should not happen, that it should not be the same point, right? The first thing is that x1 should not be equal to x2, and at the same time y1 should not be equal to y2, right? One of them can be equal, that's perfectly fine, but they should not be coinciding, right? So x1 and x1 should not be equal to x2 and y1 should not be equal to y2 at the same point of time, right? Apart from this, the second condition that's given to you is that what you have to do is you have to count for all those points which have the same Manhattan distance and the Euclidean distance. Now what is Manhattan distance? Manhattan distance is nothing but this thing. If you will see the definition, so it's nothing but mod of x2 minus x1 plus y2 minus y1, right? So mod of x2 minus x1 plus mod of y2 minus y1. So this is the Manhattan distance, right? This let's denote it by m. And what is the Euclidean distance? Let's denote it by e. So Euclidean distance is nothing but under root of x2 minus x1 whole square plus y2 minus y1 whole square. Now if you will see, so you will be thinking, right, you will be thinking that let's suppose that you have been given the points a as x1 y1 and b as x2 y2. So how will you determine whether you can easily determine the first condition, whether x1 is equal to x2 and y1 is equal to y2 at the same time or not, right? Whether these points are coinciding or not. But how to check for this condition, whether the Manhattan distance is equal to the Euclidean distance or not? So what you can easily observe is that these two equations will be equal. These two equations are going to be equal only on two conditions, right? Or you can say rather three conditions. The three conditions are, let's denote it by this thing. Let's denote this like 1. The first condition is that if x1 is equal to x2, right? If x1 is equal to x2, then you will be able to observe that if x1 becomes x2, then this part of the equation will become what? 0, right? And similarly this part also becomes 0. And if you consider this, so this is nothing but Manhattan distance between nothing but mod of y2 minus y1, and you will see this part that this is nothing but under root of y2 minus y1 whole square. So this will also come out as mod of y2 minus y1. So these two equations would become equal, right? Another case when these equations can become equal is when instead of x1 and x2 being equal, what if y1 and y2 is equal, right? So second condition is when these two equations can be equal, when the Manhattan distance can be equal to the Euclidean, is when y1 is equal to y2, right? Because if you will see, then when y1 is equal to y2, in that case what basically happens is you will be able to observe that this part becomes 0. Similarly this part also becomes 0 in this equation, right? And after this happens, so you have this the Manhattan distance is nothing but mod of x2 minus x1, and similarly this under root you have x2 minus x1 whole square, and when it will come out, so it will be nothing but mod of x2 minus x1, right? So this is when it can become equal. Now there can be a third condition as well when they can be equal, right? The third condition can be that when it happens that both x1 and x1 is equal to x2, right? And it happens that y1 is equal to y2. But this can also happen, right, when these two are equal. So in that case what will happen? X1 minus x2 will be 0, y1 minus y2 will be 0, and here also it will be 0, right? So both the equations will become 0. But it is saying that you have to find the Manhattan pairs of points which are having the same Manhattan and the Euclidean distance, and the points should not coincide, right? You can see the first condition that is there, that x1 the points should not coincide, right? So if you are considering 1, 3, right, and 1, 3, if both x and y are same for both the points, in that case you will not be considering this kind of a pair, right? So this is what you have to do in this particular question. Now you will think that how you can do it, right? So basically you can apply the concept of hashing, and you can say that how can you count the answer, right? So let's say if the question, let's say one of the cases that's been given to you, let's say is this kind of case where you have where you have 1, 2, then you have 2, 3, and let's say you have 1, 3 as well, right? So how many pairs do you have? So you can easily observe that one of the pairs, the very first pair for this could be that what you do is you have 1, 2, right? and you have 1 comma 3, right, where the if the x coordinates are same, right, where x1 is equal to x2, if this is same, then the Manhattan distance, then the Euclidean distance is equal to the Manhattan distance. The second case could be that when y points are same, right, so in that case you can say that when the points 2 comma 3 and 1 comma 3 you consider, in that case y1 is equal to y2, in that case also Euclidean distance is equal to Manhattan distance, right. So for this the output will be 2. There are two distinct kind of pairs, right. But what if like you will be able to observe that basically you need to count the points that are having the same x-axis and the y-axis, right. You will think in this manner, but think about this case as well. Let's say if you have been given 1 comma 1 and you have been given 2 comma 3 and 1 comma 1, right. So in this case you will think that the first pair will be having the x coordinates as same, that is nothing but 1 comma 1 and 1 comma 1, and you will say that for this x1 is equal to x2, right. So this is having the x coordinate as same, right. You are counting it one time for x coordinate as same, then second time you will say that what is happening, 1 comma 1 and 1 comma 1 pair, when and you will say that y1 is equal to y2, you will count it as the coordinate that are having the same y points, right, y coordinates are same. Then for the third time maybe you can say that 1 comma 1 and 1 comma 1, when what is happening, x1 is equal to x2 and y1 is equal to y2, right. But this condition has been neglected, right. This question says that you don't have to consider this kind of a pair, and what you can easily observe is that in this question what is happening is in this particular part x1 is equal to x2 and y1 is equal to y2, it is basically you are counting it here, right. You are counting one time here and one time here, so total 2 counts you have made. But you can easily observe that since the x1 is equal to x1 is equal to y1 and x2 is equal to x1 is equal to x2 and y1 is equal to y2, in that case you will not be considering this point, right. So actually you have counted it 2 times, right. You have counted it one time when the x is equal, one time when the y is equal, but you need to subtract 2 from it, right. Why do you need to subtract 2 from it? Because you should not be considering it, right. There is one such pair 1 comma 1 that is occurring same time, so 1 comma 1 is occurring 2 times, so that is you must have counted it one time when the x1 is equal to x2 and another time when y1 is equal to y2, so you will subtract 2 from it, right. So this is how you will be doing it. Now let's try and understand. Let's say if we have been given a case where we have, let's say, 1 comma 3, we have, let's say, 1 comma 4, and we have, let's say, 1 comma 5, right. So what you will do in your map, initially you will have this, right. Initially your, let's say, the counter 1 you are considering as the number of points that are having the same x-axis, right. So in that case what you will say is in your map you will keep on incrementing, so you'll say that the number of points with the coordinate 1 having 1 as the x-axis is what, currently it will be 1, right. So you'll say it here, right. After this part, what basically how many pairs you can have. So if you will try to observe, so how many pairs you can have, right. So this 1 comma 3 can pair up with this guy, 1 comma 3 can pair up with this person as well, and 1 comma 3 can pair up with this as well, right. So there will be total 3 pairs, so you'll keep on counting the pairs one by one. So that's how you will be implementing the question, and after you have implemented it, so you will keep counter 1 for counting the number of points that are having the same x-axis, right. For the counting the number of pairs that are having the same x-axis, you will be having the counter 2 for counting the pairs that are having the same y-axis, counter 3 for counting the pairs that are having same x-axis and y-axis, and after this you will do counter 1 plus counter 2, because you will be adding the number of points that are having the same x-axis, that will be the Euclidean distance when the x-axis is same, Euclidean distance when the y-axis is same, adding both of them and subtracting 2 into C3. And what is C3? C3 is nothing but when the x and y axis are the same, right. So this is what you will be doing, right. And if I'll give you a basic example, so as I told you, if you take, let's say, the pair 1 comma 3, 1 comma 4 and 1 comma 5, in this case how many pairs you will be having? You will be having a total of nothing but 5 pairs, right, like 3 pairs, right. Basically this kind of pair, this and this, then this and this, and you can say this and this, right. So total this much pairs, so you will be counting it with the help of a map and the counter, right. So let's try and implement the code for this particular approach. What you will be having is, you will be having, let's say, int counter 1 as 0, that is counting the number of pairs that are having the same x-axis, counting the number of pairs that are having the same y-axis, right. And after this y-axis, and after this counter 3 for having the counting the pairs that are having same x and y-axis, right. So in that case they will be neglected from the answer, right. What you'll have is, you will have map of int comma int, let's say map 1 for counting the pairs that are having the same axis, map 2 for having the counting the pairs that are having the same y-axis, and then after that what you will be having is, you will be having a map of pair int comma int, wherein what you will be doing with this particular pair, map 3, you will be counting the pairs that are having the same x and the y axis, right? Because you need to subtract them from the final answer. So you will start iterating, and what you will do is you will iterate through all the endpoints. Int I starts from 0 and I is lesser than n, then you do an I++, and what you will do is you will count one by one, right? So let's say what you will do is map of x of I++, you will increment this first, then you will say map of y of I, that is incrementing the count of the points that are having the same x-axis, y-axis, then incrementing the count of the points that are having the same z, not z-axis, basically incrementing like map of 1 and map of 2, that is incrementing the count of the elements, the points that are having same x-axis, incrementing the count of elements that are having same y-axis, incrementing the and after that you will increment the count of map 3, in which you will be incrementing the count of pairs that are having the same y-axis, right? So this is what you will be doing. Now once this part is done, right, so you will be incrementing this. Now once this part is done, so you will update your counter 1, and now you will update the total number of pairs that you can have, right? So as I said, you will be counting it. So counter 1 plus is equal to nothing but map of x of I, right, counting the number of pairs that are having the same x-axis. Then counter 2 plus is equal to nothing but map 2 of y of I, that is counting the number of pairs having the same y-axis, right? And after this, counter 3 will be what? Counter 3 will be nothing but mp3 of what? xi comma yi, right? This is what you will be doing. And after this part is done, so basically you will return what? You will return nothing but counter 1 plus counter 2, that is the number of the Manhattan distance for the points that will be same for the points that are having the same x-axis or the same y-axis. So you will increment the you will add both of them, and subtracting for what? Subtracting nothing but twice the count of C3, right? That is nothing but the pairs that are I am considering again and again. As I said, for when the point is 1, 1 and 1, 1, in that case you will be considering it one time. You will be counting it one time when the x-axis is same, counting it one time when the y-axis is same, but you have counted it twice. But actually the thing is that x and y axis both are same, so you should not count this kind of a pair, right? So for that you will subtract from it 2 into counter of C3, right? For that is nothing but 2 into 1 you will be subtracting, right? So that's why total count will become 0 in this kind of case, right? So that's what you will be doing. Let's try and quickly compile this and see if it works on the samples. Okay, so we are getting some compilation error. So in this case what we need to do is we need to do this thing, right? I was missing a bracket. Let's try and compile now, and you can see that we are not getting the expected output here. So counter 3 plus is equal to, I should write, okay? Now I think it will work on the samples. Counter 3 plus is equal to, now I can see that I am getting the count as 0. Let's try and quickly submit this code and see if it works or not. So you can see that this particular solution was able to pass all the test cases. Now talking about the time complexity of this particular approach. So the time complexity, since I'm using a normal map, so the time complexity will be order of n log n, right? It will be nothing but order of n log n, and the space complexity will be nothing but order of n. Thanks a lot for watching.